would it be if the next cosmic mystery was found by volunteers peering into radio maps? And what if plants carry a 500 million year old switch to survive heat waves? Those are the two stories we'll talk about today. Welcome to This Week in India's Science. I am Subhra Priyadarshini. Let's explore a community-driven cosmic discovery and a molecular secret that plants use to beat the heat. Astronomers have recently discovered a giant odd radio circle, one of the most powerful ever seen, with help from citizen scientists. This circular radio structure was spotted during a survey of distant low-frequency radio sources. The discovery expands a mysterious class of radio galaxies whose origin remains uncertain. What makes this find special is how public participation played a role. I spoke with Ananda Hota at the University of Mumbai, who led the research team, about how they engaged volunteers and the deep meaning behind these cosmic rings. I'm curious how you mobilized citizen scientists for this project.
They are coming from any university, any home, any society, any part of India. So I keep training them in Facebook online weekend classes to how to interpret and how to understand the GMRT images and other telescope images. This ORC was found from LOFA, the European Radio Telescope. There is more sensitive images that's coming. It is thrilling to see that your discovery is the farthest the citizen scientists have found, farthest and the most powerful. So that is why it attracts everybody to push the limit. How can we see more which are closer to the formation era of galaxies, that kind of thing? When the activity in galaxies peaked, that is called cosmic noon, it is redshift 1. And that cosmic noon, when the star formation activity, black hole activity, all peaked in our universe around redshift 2 to 3. This is the redshift 1. So we are going closer to that era. So that is exciting.
And on the scientific side, what is the origin of these brilliant rings? How does this discovery contribute to our knowledge of the universe's structure and evolution?
Stars that we see in the night, this is hydrogen converting to helium, like our sun. But there are billions of 100 billion stars in a galaxy. And there is something outside the stellar distribution of galaxies light that radio astronomers see, that is seen only in radio band. So it is not made up of stars, it is not made up of atoms and molecules. It is made up of electron, positron, which are close to the speed of light they are moving. So different kind of radiation comes out. So that is what is the first puzzle, that these radio rings that we spotted with the help of citizen scientists, it is far, far away from the galaxy which emits light, the visible light that human eye can see. So what is the origin of this huge ring around some rare type of galaxies that astronomers do not know currently? We have multiple speculations whether the galaxy is doing something to create this, whether the black holes are doing something to create it, we do not really know. So that puzzle is first to solve. Then we will be understanding what is its role in the galaxy's evolution or black hole's evolution or history of this kind of odd radio circle in our universe. We will go to the next step later on. Next step is to train AI/ML and use citizen scientists to find many of them. Because the next ORC will be discovering maybe slightly different. They all will help us constrain various models that we have proposed. What exactly is the real origin? We will be able to figure out by discovering more such ORCs. The Indian Radio Telescope, GMRT, had produced a lot of data, had produced an image of the whole sky, 90% of the sky, at radio waves having a wavelength of 2 meters. I started training university students and citizens who have done BSc BTech degree to understand what the image says. So I trained them to find out the uncommon radio sources, the typical radio galaxies, how they look like. So that anything which is not looking the standard structure, I want them to spot it. Because this kind of odd sources could be sign of past activity of black holes accretion. But in that training and in that search process, the student basically found this particular source. And he found it like saying that it doesn't look like any radio galaxy. It is very strange. It looks like two rings. Multi-wavelength, the optical galaxies are behind it. Some are confusing galaxies. Radio emission from one telescope looks like that is another telescopes, the radio telescope do not show the image at all. It only shows the center. There are many complex issues involved. That's why citizen scientists are good at collating all the images and information and trying to make sense out of it. I realized it is very, very extremely rare. Only one such double ring ORC was known before.
Like we heard, while the precise origin of these circles is still debated, possibilities include shock waves from galaxy mergers or plasma phenomenon in intergalactic media. This new detection, especially at such strength, gives fresh constraints to theories. In the coming years, more ORCs found by citizen telescopes may fill the gaps of how matter, energy, and magnetism weave the cosmic web as we know it. Read about this fascinating research on Nature India this week. On our home planet Earth, plants have their own survival toolbox. A new study has uncovered a conserved molecular circuit, likely dating back to the dawn of land plants, that helps them sense and survive heat stress. A team led by Ranjana Yadav at the Indian Institute of Science in Bengaluru showed how plants integrate temperature cues via a molecular switch that modulates protective gene expression. This switch, which likely evolved 500 million years ago, helps plants manage heat response more precisely, turning on defenses just when needed. Now, why does that matter? As global temperatures rise and heat waves intensify, crops engineered to harness this switch could maintain yield stability in hotter conditions. So this week we journeyed from cosmic rings born in the depths of space to molecular gears tuned over eons in green leaves. In one case, community eyes help us see farther into the universe. In the other, evolution's ancient wiring helps plants survive on a warming Earth. Thank you for tuning in. If you enjoyed this episode, please share it, rate it, or tell a friend who loves science. I'm Subhra Priyadarshini, and this is This Week in India's Science.